All right, ready to dive into some quantum stuff.
Let's do it.
Today, it's quantum boosting.
Sounds pretty intense.
Yeah, and we're looking at this essay, Quantum Boosting Algorithm for Schneller KI,
Okay.
which translates to Quantum Boosting Algorithms for Faster AI.
I see.
It's by Jorgo Schneeppert.
Interesting.
And, you shared this with me because you were curious about how quantum computing can make AI even more powerful.
Exactly.
Yeah. Well, to be honest, I am too.
It's a pretty hot topic, right?
Definitely.
And for good reason. Schneeppert, he really lays out how it's not just about speed, though.
Right.
That's a huge part of it.
Yeah.
He actually argues that quantum boosting could reveal patterns in data that traditional methods just completely miss.
So not just doing the same things faster, but doing totally new things.
Yeah, basically.
But okay, before we get too far ahead of ourselves, let's just make sure we're all starting from the same point. For someone who's maybe heard of boosting, but not really sure what it is, can you give us a quick, recap?
Sure. So imagine you have a team of, let's say, detectives.
Okay.
Each with their own strengths, their own weaknesses. They're all, decent on their own, but none of them are, super brilliant.
Right.
But together, they can pool their knowledge, pool their insights, and crack even the toughest cases, right? That's essentially what boosting does in machine learning.
Okay.
So it combines a lot of weak learners, which are like simple algorithms, to create a quote-unquote strong learner.
Okay.
That can make super accurate predictions.
I see.
Yeah.
So it's like a team effort, even in the world of algorithms.
Exactly.
Okay, cool. Now, where does quantum computing come into all this?
Quantum computing basically supercharges the team, right?
Okay.
Instead of just pooling knowledge.
Yeah.
Imagine these detectives suddenly have superpowers. That's kind of what the unique properties of quantum computers offer.
Right.
Like superposition, entanglement.
Right.
And these things allow the quantum boosting algorithms to explore solutions in a way that's totally different.
I see.
And potentially way faster and more insightful.
Okay.
Yeah.
Now, you mentioned that Schneeppert goes into quantum AdaBoost specifically.
Yeah.
What makes that stand out to you?
So he argues that quantum AdaBoost isn't just about speeding up existing processes. It's about making them, smarter, more efficient.
Got it.
He uses this really interesting analogy.
Oh,
he compares it to, searching for a grain of sand on a giant beach.
Okay.
Instead of, sifting through every single grain amplitude amplification, which is a key idea in quantum AdaBoost, it basically lets us just zoom in right on the area where that grain is most likely to be.
So instead of brute forcing our way through tons of data, quantum AdaBoost helps us just pinpoint exactly where to look.
Yeah.
Okay, that's a super helpful image.
It is.
And this efficiency, it's crucial because, like Schneeppert points out, we're dealing with more and more data, like massive data sets in every field, right?
Absolutely, yeah.
He also talks about something called hybrid approaches to quantum boosting, right? What's the idea behind those?
So hybrid approaches are cool because they acknowledge that we don't have to wait for, perfect, super powerful quantum computers to start, getting the benefits.
Okay.
They combine the classical boosting with quantum optimization techniques.
Right.
Basically, we're using the best of both worlds.
So it's like we're giving our detectives some pieces of advanced tech.
Yeah.
Even if they don't have the full, quantum crime lab yet.
Right, exactly. Oh. And Schneeppert actually highlights the quantum approximate optimization algorithm, or QAOA, as a prime example of this.
Got it.
He believes that, combining this kind of quantum coprocessor with the classical algorithms is key to making quantum boosting practical in the near term.
So we're starting to see how this, theoretical concept could be actually implemented in the real world, even with the limitations of, current quantum computers.
Yeah, exactly.
But before we get into, specific applications, I think it's worth pausing here.
Yeah.
To let that sink in. The idea that we can combine the best of classical and quantum computing, it's super powerful.
It really is.
And Schneeppert really drives home the point that this isn't just about, small improvements.
No.
He believes quantum boosting could lead to, entirely new discoveries, solutions that we can't even imagine right now.
Right.
Okay. So That's a great place to take a breath. And when we come back, let's look at some of those potential applications that Schneepat lays out and see just how revolutionary quantum boosting could really be.
Sounds good. Okay, so some of those applications.
Yeah.
Schneepat, he paints a pretty interesting picture of what the future could look like with quantum boosting, I mean.
He really does, yeah. I was particularly, intrigued by what he said about logistics.
Oh, yeah.
And traffic planning.
Okay.
He argues that quantum boosting could lead to these systems that optimize routes, in real time.
Right.
Taking into account all the changing traffic conditions.
It's a perfect example of how the speed and the pattern recognition of quantum boosting can transform a problem that seems mundane, but is actually incredibly complex.
Totally.
Imagine a world where traffic jams just don't exist.
Oh, man.
That would be amazing.
Yeah, that would be revolutionary.
Right.
I'm already, feeling less stressed just thinking about it.
I know, right?
But, okay, he doesn't stop there.
No. Yeah.
What about financial markets? It seems like even tiny improvements in prediction accuracy could have huge impacts there.
Absolutely.
Yeah.
So Schneepat argues that quantum boosting could lead to algorithms that can analyze market data with such efficiency and precision that they can predict trends with way more accuracy than anything we have now.
That's a pretty tempting idea for investors.
Oh, yeah.
But it also brings up some questions.
Like what?
Couldn't that kind of predictive power, especially if it's in the hands of, just a few, couldn't that lead to, market manipulation? Yeah. Or instability.
Yeah, that's a valid concern.
Right.
It shows how important it is to consider the bigger picture as quantum boosting develops.
Right.
It's not just about building powerful tools. Yeah. It's also about making sure they're used responsibly.
Right, ethically.
Exactly.
So the applications, it seems like they're endless. What other fields or industries does Schneepat highlight?
Well, he talks about medical diagnosis. Okay. Specifically cancer.
Oh, wow.
And he says that quantum boosting's ability to find those subtle patterns in medical data, it could lead to earlier diagnoses and more accurate ones, which could drastically improve treatment outcomes.
That's truly life-changing.
Yeah, early detection is so important for so many diseases.
It makes you wonder what other medical mysteries we could solve with this kind of analytical power.
Right.
Okay, and then there's AI, right?
Yes.
Artificial intelligence.
There is.
And autonomous systems.
Yep. Schneepat suggests that quantum boosting could lead to even more sophisticated AI.
Oh, wow.
With much quicker and more accurate
Yeah.
Image and voice recognition.
So we're talking self-driving cars.
Yeah.
That can really handle anything.
Uh-huh.
Virtual assistants that like understand us perfectly.
Yeah.
And maybe even AI that can help us solve like the biggest problems facing humanity.
Exactly.
It's mind-boggling.
It really is.
But Schneepat's also realistic.
Yeah. Yeah.
About the challenges, the limitations that we need to address as quantum boosting develops.
Yeah.
And I think it's important to acknowledge those, not to like dampen the excitement,
right,
but to make sure we develop this technology responsibly.
Absolutely.
So what are some of the like key roadblocks?
Okay, so one of the biggest challenges is that quantum computers are still like babies. They're in their early stages.
Yeah.
They're limited in how many qubits they can handle. They're prone to errors.
Right.
And they can only stay in a stable quantum state. Yeah. Which is called coherence time for a limited amount of time.
Okay, so it's like trying to run a marathon with a brand new pair of shoes that haven't been broken in.
I like that.
You might have all the potential, but there can be some bumps along the way.
For sure. That's a great analogy.
And it's not just the hardware, right?
Yeah.
Developing the algorithms, that can actually use the power of quantum computers for boosting.
Yeah.
That's another hurdle.
Absolutely. And Schneepat talks about the challenges of scaling up those quantum boosting algorithms so they can handle like real world problems and then encoding classical data into quantum states and dealing with errors.
Yeah.
It's a tough dance
between
the elegance of the algorithms and the limitations of the hardware.
It sounds like a fascinating field.
Oh, it is.
But really demanding.
It is. It needs collaboration, ingenuity. Schneppe actually highlights the importance of researchers from all sorts of fields. Physicists, computer scientists, mathematicians.
Right.
All working together to push the boundaries.
It's a reminder that innovation, it often happens when different disciplines come together.
Exactly. And it's also about bridging that gap between the theoretical potential of quantum boosting and what our current quantum computers can actually do.
Right. So how do we do that?
Well, he mentions a couple of strategies. One approach is to develop algorithms specifically for what are called noisy intermediate scale quantum devices or NISQ devices, which is what we have now.
So instead of waiting for like perfect quantum computers, we're figuring out how to use what we have.
Yep. These NISQ algorithms, they're designed to be more tolerant of errors and to work within the limits of the current qubits and coherence times.
Got it.
So it's finding that sweet spot between ambition and what's actually possible.
And that leads into another approach Schneppe talks about, leveraging quantum annealing techniques.
Yeah.
What's that about?
Quantum annealing is super interesting.
Okay.
It's for optimization problems. So imagine you have like a complex landscape, peaks, valleys. And you're trying to find the lowest point that represents like the best solution.
Got it.
Quantum annealing uses quantum mechanics to efficiently explore that landscape and find that lowest point.
So instead of searching every little corner, we're using quantum mechanics to tunnel our way to the best solution.
That's a great way to put it.
And the cool thing is, quantum annealing hardware, it's becoming more available.
It is.
Which opens up new possibilities for quantum boosting.
Yeah.
Seems like there's a lot of creative thinking happening in this field.
Definitely.
Trying to figure out all the different ways to harness quantum computing for boosting.
Absolutely. And that's what makes it so exciting. It's constantly evolving.
Yeah.
It's a constant push.
To find new and better ways.
To make quantum boosting a reality.
Exactly.
Well, I gotta admit, I'm feeling a little overwhelmed.
Yeah, that's a lot.
It's a lot of information.
It is.
I think our listeners probably need a moment to digest all this too.
Yeah, for sure.
So let's take a quick break.
Okay.
And when we come back, we'll wrap up our exploration of quantum boosting.
Sounds good.
And talk about what it all means.
Awesome.
Okay, we're back. And I feel like every time we talk about quantum boosting, we just like uncover more and more complexity.
But really is a field that keeps on giving, you know?
It does.
But even with all the like nuances and challenges, there's just this like sense of excitement and potential.
Right.
It's hard to ignore.
Absolutely. So as we wrap up our deep dive into Schneppe's essay, what are some like key takeaways?
Well, I think Schneppe, he does a really good job of showing the potential of quantum boosting.
Yeah.
This isn't just a minor upgrade to AI.
It has the potential to completely change how we solve problems, how we make decisions, even how we understand the world.
It's that idea of going beyond just doing things faster, right?
Ridiculous.
It's doing totally new things.
Yeah, things that were impossible before.
Yeah, he also highlights the importance of the how.
Yes.
Like, it's not enough to just have these powerful quantum computers.
Right.
We need to develop the right algorithms, the right approaches to actually use that power.
For sure.
And that's where it gets really interesting.
It does.
Right? Like we have these different strategies popping up, NISQ algorithms, quantum annealing, each with their own like strengths and weaknesses.
Yeah. And it shows that innovation often requires us to be adaptable, you know?
Right.
To explore different paths, to be open to the unexpected.
So it's not just about the destination.
Yeah.
It's about the journey.
I like that.
And I think another important takeaway from Schneppe is this emphasis on collaboration. Like, this isn't something one brilliant person can solve alone.
No, not at all.
It's going to take physicists, computer scientists, mathematicians, engineers, ethicists, policymakers, everyone
working together
to push the boundaries.
But also to make sure it's done responsibly.
Right. Ethically.
Exactly.
And that brings us to another key point.
Okay.
This technology is changing so fast.
It really is.
What we know about quantum boosting today is probably just the beginning.
It's the tip of the iceberg.
So stay curious.
Yeah.
Stay informed. Stay engaged.
Yeah.
because this is going to shape our world in huge ways.
It really is.
And a huge thanks to Yorgo Schnippat.
Yes.
For this awesome exploration of quantum boosting.
His essay is great.
If you want to learn more, definitely check it out.
Yeah, highly recommend it.
Until next time, keep exploring.